Does your new building project require a photovoltaic system, also known as a PV system, according to the Energy Code? If so, one of the methods you would use to determine the code-compliant minimum PV sizing for your project is the SARA method. The SARA method allows for a tailored PV design that considers the actual conditions and design of all roof areas. It is particularly suited for small roofs, partially shaded roofs, and roofs with many obstructions. In this video, we'll look at Energy Code criteria for calculating the SARA and how you use it to determine the minimum PV capacity for a project. SARA stands for Solar Access Roof Area and refers to the usable roof spaces of your project that receive sufficient sunlight throughout the year. Usable roof spaces encompass all areas in the project scope that are capable of supporting a PV load, including carport roofs. When other building codes have requirements that do not allow putting PV in certain locations, such as allowances for HVAC access and PV egress, those areas are omitted from the SARA. Other factors that determine usable roof space include roof structure, orientation, and composition. A key factor is sunlight exposure. In this example, the purple shading indicates roof areas with less than 70% annual solar access and cannot be counted as usable roof area. In some cases, you may want a solar assessment study to help accurately define the SARA. In a shading analysis like this, nearby buildings, trees, and other obstructions can be counted as shaded areas to exclude from the SARA calculation. The California Energy Commission has approved several shading assessment tools you can use to evaluate the suitability of roof areas for solar PV installations, specifically for SARA. These tools help accurately measure and account for the shading from nearby objects, like trees, buildings, or other obstructions, ensuring that only areas with adequate sunlight exposure are considered in the SARA calculations. When calculating the PV capacity requirement using the SARA method, you would use a different formula for low-sloped roofs, with a pitch less than or equal to a 2-inch rise per foot of run, versus steep-sloped roofs that are greater than 2 and 12. When your project has both types of roofs, calculate the PV capacities separately for each type. Then combine them for the total minimum PV capacity. For example, if a house in Los Angeles has 500 square feet of usable low-sloped roof space that was determined to receive sufficient sunlight, then this is the total SARA. Multiply that by 14 watts per square foot, and the PV capacity requirement is 7,000 watts, or 7 kilowatts. In this example, a multifamily building in Los Angeles has 2,000 square feet of low-sloped usable roof space that receives sufficient sunlight, and 1,000 square feet of steep-sloped usable roof space receiving sufficient sunlight. First, we take the low-sloped SARA of 2,000 square feet, multiply that by 14 watts per square foot, and get a PV capacity of 28,000 watts, or 28 kilowatts. Then we take the steep-sloped SARA of 1,000 square feet, multiply that by 18 watts per square foot, and get a PV capacity of 18,000 watts, or 18 kilowatts. We then add these two ratings together for a total PV capacity of 46 kilowatts. Remember to include all roof spaces associated with the project that are structurally able to support PV, such as the roofs of carports and covered parking. Depending on the building type, additional considerations and exceptions may apply. See the Energy Code ACE website for fact sheets and training. Do you have questions or suggestions for more topics? Leave us a comment, and be sure to check out these resources.